In this section, we're going to cover the second type of primitive data types in JavaScript, which are numbers. And there's a lot more to cover in numbers than there were in Booleans. And so we're going to move kind of fast, and I would encourage you to rewatch this video a couple times until it sinks in well before moving on with the next section. But without further ado, let's go ahead and jump right into talking about numbers in JavaScript. The first type of numbers that we can assign to variables are integer numbers. These are simply whole numbers, as we might expect. So here we see nothing new. I simply declare a variable called example number and assign the value 1 to it. We can also deal with floating point numbers. So here I have just simply assigned the value 1.1, which is a floating point number, to our example number variable. We can also make numbers negative, both integers and floating point numbers. And we do that by simply adding this negative sign in front of the number. So here I've added the negative sign to an integer or whole number 1 and assign that to our example number. Moving forward, we can look at the min and max values of numbers in JavaScript. And the first one that we'll look at is the max value, and we grab the max value of numbers by selecting number, which is a JavaScript global variable or global prototype, and then selecting its max value field. And in this case, this max value is a constant, which is why it's all capitalized. Then we're going to go ahead and console.log that example number of max value to our console. And we can do the same thing with min value. Now, there are some cases where we don't necessarily want to deal with max value and min value. We're more concerned about conceptually something like infinity. This can come in handy if we're doing sorting of numbers or things like that. And JavaScript provides us another global prototype called infinity that we can use in these cases. And we can create negative infinity by simply assigning a negative value in front of the infinity global prototype. And it's worth pointing out that we're probably not going to use these four things all that much in our programs, but they're worth understanding and they're worth being made aware of. And we'll go to the browser to see exactly how each of them behaves when we log them to the console. And when we log them to the console, we'll see that the max value is a really big number, the min value is a really small number, and then the infinities are not numbers, but rather concepts. However, we'll see that they're still treated as numbers by JavaScript, and so we can do comparisons, in which case infinity will always be greater than any number we compare it to, and negative infinity will always be less than any number we compare it to. So it could come in handy depending on the types of programs that we're going to run, but we should rarely find ourselves bumping up against these upper and lower bounds of number values in JavaScript. Moving on, there may be times where we're dealing with floating point numbers where the number of decimal places in the number is large, and we want to truncate that down to only a few in order to display nicely to our users. We can accomplish this using the toFixed method that JavaScript provides us. And in this case, we demonstrate this toFixed method by creating a number 100.12345, assigning it to our example number variable. And then we log out our example number before we set it to a fixed number of decimal places, and again after we do it. So let's go to our console to see exactly how this looks. And we'll see that it accurately truncated our number with 5 decimal places down to one with only 2 decimal places. But there's something fishy going on here, which is that our number initially is printed out as blue, but after we run the toFixed method, it's printed out as black. And the reason for this is that after it runs the toFixed method, it's essentially interpreted as a string. And we may or may not be okay with this, but if we're not okay, we need to figure out how to convert it back into a number. And we do this by casting it as a number. And so in this case, I still call my example number.toFixed method, but I wrap this up in a number. I simply add parentheses around this method and then cast it, meaning I tell JavaScript this needs to be treated as a number. So if we go back to our browser, we should see that this example number.toFixed method returns a string, but then is cast into a number, so it should be printing out as blue again this time. Let's make sure that's the case. And indeed it is. JavaScript now interprets that new number, that 100.12, as a number because we casted it as a number, meaning that we told JavaScript to interpret that value, that data, as a number. Moving on, there may be times where we're dealing with strings or essentially non-number data that contains a number which we want to parse out of it. And so here I've created two examples where I have a string that contains what's clearly an integer value, and I want to parse that integer out of the string. So I assign the string to my example number variable, and then I log to the console first that example number before I parse out the integer, and then again after I've parsed it out. So here's what happens when I parse an int. I call this method parseInt, and I pass in my example number variable. But I could also just pass in the value itself directly. And then this parseInt method is going to parse out the first whole integer that it finds in this string. I can do the same thing by parsing a float. And so in this case, I've created a value, a string of 10.33. Again, clearly a floating point number that I assign to my example number variable. And then I call this parseFloat method, and it parses out the first complete floating point number that it finds. So let's go to the console and see exactly what happens. And we see that in the first example, I start with the string value 10, and then I parse out the number 10. And in the second example, I start with the string float value 10.33 and parse out that float, and it accurately prints 10.33. Now, one thing that we may want to ask is what happens if we try and parse an int when it's actually a floating point number, or vice versa? Well, let's go back into our text editor to create an example of that. And so here I'm just going to shortcut it and go ahead and pass in the string values directly, and I say parseInt of this string 10.33 and log that to the console, then parse this float of 10 and log that to the console. Let's go back to the console to see exactly what happens. In the first example, it only parses the 10 out of that string, and the reason for that is that the parseInt method tries to parse the first whole integer that it finds. Well, in this case, the first whole integer it finds is the number 10. It ignores the dot because it's looking for integers, not floating point numbers. In the second example, the parseFloat method accurately parses the integer value from the string. So what we've learned from this is that if we aren't quite sure on what type of number data we're going to be dealing with, either floating point or integer data, we probably want to err on the side of caution and use the parseFloat method rather than the parseInt method. But of course, there may be times where if we're not careful, we try and parse values that aren't actually numbers. So we're going to look at one more method that will help us distinguish the two. And that method is the isNaN method. And this method determines if a value is a number or not. So in this first example, I've assigned the number 1 to our example number variable, and I pass that variable into the isNaN method, which will return false because it is a number. So the number 1 should return false when passed into this isNaN method. However, if we do something like this, where we assign the value hello world, which is a string value, to our example number, then pass that into the isNaN method, it should return true because it is not a number. So let's go to our browser and inspect our console to make sure that these two examples behave as we might expect. And indeed they do. In the instance where we pass a number through the isNaN method, it accurately determines that it is a number, and therefore it is not a number. And similarly, when we pass a string through that method, the isNaN method, it determines that it is not a number. And so this method's a little bit weird because it's evaluating the negative rather than the positive, meaning it's evaluating whether it's not a number rather than if it is a number. And so we have to be conscientious that when we evaluate whatever value this returns, that false actually means the value is a number that we passed into it. Now, like I said at the beginning of this section, there's a lot of information here, and I would encourage you to review it again if it didn't quite make sense the first time before moving on to the next section, where we're going to cover the third type of primitive data in JavaScript, that is string data.